Okay, so my name is Brittnay Davis, and I am going to be factoring out two numbers. My first number is 546, and my second number is 510. Now, when I factor these numbers out, I'm going to be doing a factor tree. So for 546, this factors into 3 and 182. And we know this because these two numbers can be multiplied to equal 546. So you're just going to continue that same process. And 182 factored is 2 times 91. And we also need to check to see if 91 can also be factored. And it can, and it's 7 and 13. Now we're going to use the same method for 510. 510, once you factor this out, it's 2 times 255. 255 factored out is 5 and multiplied by 51. And then 51 factored out is 17 times 3. Now for both of these numbers, for 546, the prime factors of this number, prime factors, are 2, 3, 2, 7, and 13. So we're going to write 2, 3, 7, 13 in order. And then for 510, it would be 2, 3, 5, and 17. So 2, 3, 5, and 17. Now when finding the greatest common factor, the greatest common factor is the greatest factor that divides two numbers. So between 546 and 510, the greatest common factor would be 2 and 3, since this is a common number between the two. So we're going to take the 2 times 3, and the sum of this, the solution of this would be 6. So now we're going to find the LCM, which is also standing for the least common multiple, which means the number that is equally a multiple of two numbers. So the LCM would be 2 times 3 times the rest of the remaining factors from both of your factor trees. So this would be 2 times 3 times 5 times 7 times 13 times 17. Now, once you multiply all of these numbers out, your answer should be 46,410. Now you can also check this using the slide method. With the slide method, what we're doing is we're taking both of our numbers, 546 and 510, and we're seeing what number can be multiplied and can be used to go into both of these numbers. And we see, since this ends in a 6 and a 0, both of these numbers can be, the 2 can be multiplied into both of them. For the 546, this number can be multiplied 273 times the 2, and then 255 times 2, which would give you the 510 and then the 546. And this can also be factored once again. 3 can go into both of these numbers, and we know this because if you add up this number, 7 plus 3 plus 2 is 12. 12 is divisible by 3. 5 plus 5 is 10, plus 2 is 12, and that is also divisible by 3. And once we factor this one more time, this will be 91, and this is 85. Now, even though 85 can be factored again by using 5, 5 is not able to go into 91 because 91 is a prime number. Therefore, we're only looking at the numbers on the outskirt of your slide method. So if you take 2 times 3 times 91 times 85, your answer should also be 46,410. And you see that from your LCM and your slide method, your numbers match. So therefore, it's complete.